things and just add a couple little helpful tidbits. I have found in the past that students struggle with these topics, so I felt that it deserved an extra video all by itself. So here's some random data. This data is not anything in particular, it's just something I grabbed out of a homework assignment, so it's not important what it's about. It's just some data. And we're going to use our calculator to analyze the data. I'm going to show you how to do that in a way that is a lot quicker than doing it by hand. So I'm hoping this helps. We'll also be going into outliers and getting a little bit more detail on how to find outliers and when to use which method. So first we're going to enter this into our calculator. So I have a TI-84 emulator right here. You can also use any of the other TI graphing calculators. I believe they're all done exactly the same way. There are some things later on in this course that are different with different calculators, but this is pretty much the same across all of them. So in order to enter my data, I need to go to the lists. So I'm going to click on stat, and I need the first option, which is edit. So I'm just going to hit enter. And notice I have L1, L2, L3. So I have all of the lists. So list 1, list 2, list 3. That's what the L stands for. L1 is the data that is over here on this other screen. I'm going to leave it there. But I'm going to use this second list to show you how to clear out a list. So I have random numbers in here. In order to clear out the list, I'm going to arrow up, use these arrows on this circle. It's a top arrow, arrow up until L2 is highlighted. Notice how it is turned black, it is highlighted. To clear out this list, I'm going to hit clear, enter, and it clears out the list. Do not hit delete. If you hit delete, you're going to lose this column altogether. So just click clear, enter, and it clears it out. I'm going to do it one more time, and I hit some random numbers in here. Just put some random stuff in here, and I'm going to do it one more time. I'm going to arrow up till L2 is highlighted and hit clear, enter, and everything is clear. So in L1 is all of this data right here. I need to tell you that the most common error when working with your calculator is inputting things incorrectly. I can't tell you how many times I got some strange answer because I forgot a decimal point or just did a typo or whatever. So the first thing you do if you get the wrong answer is to go back and check and see if all of your numbers are correct. So check it against your data. So now we're going to actually use the tools in this calculator to analyze our data, and I will show you what each piece means when we get there. Once again, I'm going to click on stat and then arrow over until calc is highlighted up here on top. So it's stat and then calc. I need the first option. It says one var stats. This means one variable statistics. This is telling us that we're analyzing one variable statistics. I have one variable here, whatever this data is about, and so I'm going to analyze that. I click enter on this. So the list I am using is the L1 list, the list 1. If I was using list 2, I would change this to L2. Let me show you how to do that. So notice how above the number 2, so go look down. Above the number 2 down here in the numbers is L2. I would hit second L2, or second 2, and that would change this to L2. So if my data was in that L2 list, I would hit second L2 to change that. I'm going to clear this again. I want L1, so I'm going to do second number 1 to get list 1. Notice that it goes all the way up to list 6. So you could use the different lists. If you had different data sets that you were comparing, you could put data in all of the different lists and use them for different things. But we're using L1. Frequency list, that's what this is. So we use the frequency list if numbers show up more than once, but everything just shows up more than once, so I'm just leaving this blank. So we just want list L1, frequency list is blank, arrow down to calculate, and then hit enter. We're going to get all sorts of stuff here. Okay, I'm going to write down what each thing means. So first I have X bar. You may recall that x bar is our sample mean. So the calculator always does it as x bar, but if this was a population, it's technically mu, but your calculator is always going to call it x bar because the calculator doesn't know if it's a sample or a population. It can't tell. It doesn't know what you're studying, so it's always going to call it x bar. So this, the sigma, capital sigma x, that is the summation. This is called a summation. This is just saying that this is the sum of all of my data values. So this adds them all up. And I don't even know why we need the ex squared. I don't know what that is, but this is the square of the sum. I've never needed this for anything, but it is there if you choose it. So next we have SX. This is our sample standard deviation. This is the sample standard deviation. Remember from the previous lessons, there are the lessons this week, that sample standard deviation is calculated different than standard deviation. Sample standard deviation is divided by n minus 1. Standard deviation is divided by n. So those are going to be different values. So this next one right here, sigma x, is population standard deviation. So the sigma is population, the S is the sample. N is just how many, this is sample size, this is our sample size. Hopefully you already know what the sample size is, but we don't know. All right, so I'm going to arrow down, use my arrow key down here, and I'm hoping that all of this is self-explanatory because I'm kind of out of room. So the M is your minimum value. Your max is your maximum value. We have Q1, median, and Q3. These are necessary things in order to calculate the interquartile range, to find our outliers and whatnot. So this is all of the stuff that we use with median, and then all of the stuff up at the top, this is stuff that we use with mean. So I'm going to write some of these numbers down, and we're going to talk about how to find outliers using this data. So this is, we've already kind of gone into it in our other lessons, but I'm going to go into it and spend a little bit more time here. So I erased everything I had, and I'm going to write down the important pieces. So I'm going to write down my X bar is 17.97. I've decided that this is a population just because I'm just deciding it. So this is a population, so I'm going to use the population standard deviation just because, just for this 5.45, it's mostly because I like the number better, but I've decided this is a population. So there's my standard deviation. Then over here, in a different color because I like to, I'm going to write down my Q1. Q1 is 14.65. I left off the 1. My Q3 is 18.85. I don't need the median for anything, so these are just the things that I'm going to need in order to analyze my data. Okay, so here is, now I'm going to use this data to determine if there are outliers. So I'm going to put a line down the middle. We're going to start with the 2 standard deviation rule. So I'm going to write it down here. 2 standard deviation rule. The 2 standard deviation rule is only used when we are using the mean as our center. I guess I should have left more room. Only used when mean is center. When you are using mean, you use the standard deviation rule. When you are using median, we'll use the 1.5 times IQR rule. So only used when median is center. So do not try to use 1.5 IQR if you are using the mean, because it doesn't make sense, because we do not use quartiles when we're using the mean. We only use quartiles when we're using the median. So if we're using the mean, we use standard deviations and the 2 standard deviation rule for outliers and to compare values. When we are using the median for center, we use quartiles, the interquartile range, and the 1.5 IQR rule when comparing data and looking for outliers and things. Okay, so now let's go back to the mean and the mean and the standard deviation. I'm going to go hit second mode, and this allows you to quit. Notice the little blue quit right here. I'm back over on the calculator. Notice the little quit there. If you're in a program or something and you want to get out of it, you hit second mode, and it gets you back to our regular calculator screen. So when we are using mean and median, or mean and standard deviation, anything 2 standard deviations above the mean, so let me draw my normal curve. So here I have my normal curve. This would be the mean. This right here would be 1 standard deviation. This would be plus 1 standard deviation. This would be minus 1 standard deviation. Put another line here. This is plus 2 standard deviations. This is minus 2 standard deviations. You may recall that this area right here, all of this right here, 95% of our data lands between 2 standard deviations of the mean. So 95% of our data is within 2 standard deviations above the mean and 2 standard deviations below the mean. This is part of the empirical rule that we went over. So according to the empirical rule, 95% of our data is within 2 standard deviations of the mean. Anything outside of this is an outlier. So anything in this red zone over here and red zone over here, these are outliers. So anything outside of 2 standard deviations away from the mean are outliers. So those are outliers. This 2.5% here and this 2.5% up here, these are outliers. Anything more than 2 standard deviations away from the mean. All right, I need to make some more room to do some math. Let's erase this. Let me try to erase this pretty. Okay, it's not erasing pretty. Good thing I can rewrite it. This is 5.45. Okay, so now let's do math. So for this particular data set, I need to use my 2 standard deviation rule to determine if there are outliers. The way we do this is you take the mean and you add 2 times, man, I am bad at this today. 2 times whatever the standard deviation is, and then you do the mean minus 2 times the standard deviation. Standard deviation. Anything above this one or below this one would be an outlier. So let's do that math. Okay, so I'm going to do 17.97 plus 2 times 5.45. I'm going to put that in my calculator. I have 17.97 plus 2 times 5.45. That number is 28.87. Now I'm going to do 17.97 minus 2 times 5.45 and get what that number is. So over here on my calculator, 2 minus, that's not what I was trying to do, 17.97 minus 2 times 5.45 is 7.07. So anything above 28.87 is an outlier. Anything below 7.07 is an outlier. Therefore, if we look up at our data set here, we do not have any values lower than 7.07. But I do have this value here, this 38 right here. That right there is an outlier. Because it is more than 2 standard deviations away from the mean. Once again, that is more than 2 standard deviations away from the mean, so is an outlier. So I'm going to talk about z-scores in a second because that becomes important also. But basically anything more than 2 standard deviations away from the mean is an outlier. So this 38 is an outlier. Okay, now before I jump into the median stuff, I'm going to erase again. So we've already determined that 38 is an outlier. So remember we were talking about z-scores, and believe it was in 3.4. We were talking about z-scores. So a z-score tells you how many standard deviations away from the mean a value is, and whether it's positive or negative, whether it's above the mean or below the mean. So since 38 is an outlier, it is more than 2 standard deviations away from the mean, which means its z-score should be greater than 2. So I can do this. I can find the z-score of 38, and if that number is greater than 2 or less than negative 2, it is an outlier. That's basically using the standard deviation rule, but it's kind of using it backwards. So let's take a look at what the z-score of 38 would be. So if I take 38 minus 17.97, remember this is how we calculate our z-score, and divide it by my standard deviation. So remember, a z-score is the x value minus mu over standard deviation. So I'm going to put this in my calculator. So if I was putting the whole z-score calculation in at once, I need to use parentheses. So I'm going to do 38 minus 17.97. So the parentheses make sure that all of this is considered the numerator. Now I'm going to divide by 5.45. I have a z-score of 3.67. This number is definitely larger than 2. It's definitely more than 2 standard deviations away from the mean. So that makes it an outlier. So when we are using the mean, there is one outlier, and that is 38. Okay, now let's talk about using the median, or using the IQR. So when we are using the median as our measure of center, I'm going to use 1.5 times the IQR to determine the outliers. So let's take a look at this. So I have my Q3 is 18.85 and my Q1 is 14.65. Remember that the IQR, or the interquartile range, is Q3 minus Q1. So I will do 18.85 minus 14.65. This is my IQR. So I'm going to use my little calculator, 18.85. Yes, I can do this math in my head, but sometimes it's better just to use the calculator. I will not fault anyone for using the calculator. 4.2. So my interquartile range is 4.2. So that's telling me the distance between Q1 and Q3 is 4.2. But I need 1.5 times the IQR. So I'm going to do 1.5 times the IQR. Actually, just a second here. I'm going to erase this. I need more room. So my IQR equals 4.2. So in order to find if I have outliers, I take Q1 minus 1.5 times the IQR. This gives me what's called a lower fence. And then to find the upper fence, I do Q3 plus 1.5 times the IQR to get my upper fence. Anything lower than the lower fence or higher than the higher fence is an outlier. So let's do this. So I'm going to do 14.65 minus 1.5 times 4.2. My lovely little calculator will give me that number. So 14.65 minus 1.5 times 4.2. That gives me 8.35. In order to not mix my colors up, I'm going to change colors again. So now I'm going to do my Q3, which is 18.85 plus 1.5 times 4.2. So let's do this. 18.85 plus 1.5 times 4.2, enter. Gives me 25.15. So anything lower than 8.35 or higher than 25.15, those are my lower fence and my upper fence. Anything lower than 8.35 or higher than 25.15 is an outlier. So still, even in this case, this is an outlier. 38 is still an outlier in both cases. And I do not have a lower outlier in either case. Now, I'm not always the outliers that I see in one is not always going to be in the other. Sometimes when something is severely skewed, you'll have a little bit different answers, or maybe if it's not quite as skewed. So sometimes you'll get an outlier with the mean and not with the median. And it's usually when a number is just barely an outlier. It's usually when it's just barely, like maybe there was a z-score of 2.01. It's still technically an outlier, but it's barely an outlier. And so you won't necessarily find it in both. But I don't think we have a ton of questions that ask for the outlier in both. It just depends on which measure of center you're using. So if you still have questions on this after watching this video, please make sure to post in the forums. That's always the better place, because if your classmates are having the same question as you, they can get the same help at the same time. Or go ahead and send me a message if you really want to. That's it for this supplementary video. Thanks for watching.